Hello? So, Mr. Franzetti and I would like to present to you today some new chemistry we've been working on at Siltech, and in particular fluoroalkyl silicones. Just very quickly on our experimental design, we used 5 different coating systems, a solvent-borne urethane, 2 different acrylates, so UV cured, and then a cationic epoxy UV cured material. And the last system was a commercial waterborne paint, which we post-added. I will not talk about those results much today because they're iterative, but the idea is held up there as well. In addition, we looked at various fluoroalkyl silicones and evaluated them for standard properties. These fluorosilicones are shown here. You can see that the fluoroalkyl material is, in fact, 4 carbons that are perfluorinated. So they are environmentally more acceptable than the PFOS materials. And then in addition, we put an R group on there that might be polyether or it might be hydrocarbon. So we'll talk about 3 different classes today. The FPEs are fluoropolyether materials. More on that on the next slide. Fluorosilicones have no additional alkyl group, and they're the least compatible. And then the fluoroalkyls, which have additional compatibility, where R is an aliphatic hydrocarbon. It's a very important slide to understand what we're doing. So these are the materials, and these are actually codes. In the US, it's bad form to use product names, so these are just little tricky codes. We have product names if you want to talk to us outside. So the first 2 are fluoropolyether materials. These have polyethylene oxide on them to increase the solubility. And in fact, you'll notice they're both miscible in water, 1 up to 10%. So if you look at the weight percent in that second column there, they're relatively small amounts of perfluoroalkyl materials, 8% and 3%. We expected that these things would be very good for flow and leveling, but not very good for slip. It's one of the surprises of this talk is that they were in fact very good. The next category is the fluorosilicones. The highest fluorine content there is 44%. We expected this to be the highest performance, to give us the best slip, the best stain resistance. In fact, that also turns out not to be true. So that's the interesting things here. The last category is fluoroalkyl materials. These are new developmental materials, and you can see we have a range of 40, 30, and 17%. That 17% one is also acrylated so that it reacts into the UV cured coatings. Again, we expected that the FA3 would be the least effective, and it turns out that's the interesting one. The last material there is the hydrocarbon modified material. So I'll present the results. This is just a quick overview. You can see the control on the top. All of the slip has been reduced in all of the systems. The gloss is reduced slightly, but in one case significantly. The mar resistance is dramatically improved. And in most cases, the coating is good. There are a few fisheyes. I'm going to take this same data from this slide and put it in chart format. So this is much easier to see. This is exactly the same data. So now just gloss. Notice the range is narrow, 100 to 130 degrees. These are subtle differences. But you can see the control on the left. And then most of the products reduce that. The 2 all the way on the right-hand side are the fluoropolyethers. They're very compatible, so they do not reduce gloss. The ones that reduce gloss are the same ones that create the defects. This is in the UV cured system. You see a very similar result. The purple and blue columns in the middle are the fluoropolyethers, very compatible. The other materials do reduce gloss and in some cases cause defects. In this, another UV cured system, they're very compatible and nothing is really impacted here. Now looking at mar resistance, see the control all the way on the left is a very low value. Everything improves mar resistance. We see the same thing in the next system. Now this is UV cured. and the brown bars now indicate fingerprint resistance. So now you start to see an interesting result because not everything improves fingerprint resistance. In fact, the fluoropolyether materials, which are very good at mar resistance, we're surprised by that, they're not very good at fingerprint resistance. So the one property that really needs high fluoro content is the fingerprint resistance. This is the third system. It's another UV cured system. You see the same thing. Mar resistance in blue is improved in all of them. Stain resistance in orange is improved in all of them. And fingerprint resistance, again, is quite low in the fluoropolyether materials. But the other interesting thing, and we'll see this over and over again, is this one structure here. This is the one that was only 17% fluorocarbon. It's really a very effective material, and it's typically the best material on each of these slides. So you get a very good balance of properties here. This is all that same data on one slide, a little bit hard to see, but you can see that the fluoropolyethers are very good for mar resistance. And this second from the right, that's the Fa3ACR. It's a very effective material. Fingerprint resistance, you see the same thing. The two on the right are very effective as well. Looking at slip now, a coefficient of friction reduction. Again, everything reduces this. Sorry, there's two bars, one's static and one's kinetic. Control is on the left. Everything reduces coefficient of friction, but the FA1, which has the highest percent fluorocarbon, is not the lowest slip. That's surprising. In fact, the Fa3ACR is the lowest. In the UV cured system, we see that same thing. The FS1 now is pretty good, but still the Fa3ACR is better. So there's a synergy here between the silicone and the fluorocarbon. It's not enough to have the highest fluorocarbon possible. You want to have both. Same thing in the other UV cured system. That highest fluorocarbon material is not the best, but the Fa3ACR is excellent. This is that same data shown all in one case. I'll move on from this. Looking quickly now at stain resistance. All the products are down the bottom. Each bar represents a different stain. The first grouping on the left is the control. And this FA1 is the highest fluorocarbon content material. It is not the best for stain resistance. In fact, the FPE1 and 2 are not very good here, but the FA3, both acrylated and not acrylated, are quite good. You can see that product is the one that we're favoring. Now in the UV cured system, the FS1 is really not very good at all. The fluoropolyether materials and the Fa3ACR are very good. And now the other UV cured system, you see the same effect. The same products are very good. So a quick summary, and then I've got one more system. All of the FAS additives do improve COF, mar, and stain resistance, to a lesser degree fingerprint resistance. The fluoropolyethers are compatible, but they still give good slip, mar, and anti-stain, which was somewhat surprising. They are weak on fingerprint resistance. The Fa3ACRs and the fluoropolyethers give relatively high ratings for gloss, mar, and stain resistance. I didn't talk about the stains much, but the waxy stains are better. The crayons were very good here. There are three products that give very good fingerprint resistance, and the FA4 gives actually a very good balance. It is not water soluble, so I haven't emphasized that much. It's the last system. Now here we're talking about a purely silicone resin. It's a cationic UV cure, and because it's silicone, you would not expect these things to reduce slip much. In fact, that's what we'll show. I wanted to show you this result because it does talk about use levels. Everything to this point has been at 1%. So here we're doing a ladder study from 0.2 to 5%. There's no point in going through all this data. I'm going to show it to you graphically. So what you see in the different colors is 4 different additives, each of them at 5 different use levels. And you can see that as you increase the concentration, the gloss goes down. So the more of these materials you use, because they're somewhat incompatible, the more gloss is reduced. This is looking at slip, and I'll just highlight sections. This additive is the very high fluorocarbon content material. It does reduce slip because fluorocarbons are more slippery than silicones. It's the only additive that really significantly reduces slip, again, because the resin is silicone. But even here, you can see the impact of use level. The more you use, the more slippery it gets, at least up to about 3%. So now this is the fluoroalkyl material. Of all of those, of the next three, it's the highest fluorocarbon. You can see an impact at 1%. In the moderate, you see very little impact. And in the lowest fluorocarbon, it doesn't really reduce slip. Now this is looking at mar resistance and stain resistance. Again, highlighting those sets. You can see that the more you use, the more effect you get in both fingerprint resistance and mar resistance, and stain resistance, sorry. I'm sorry, mar resistance and stain resistance. Same thing happens here, and here, and here. So the summary here is all these materials are compatible with the silicone resin. Gloss is reduced slightly. There's no surface defects. The more product you use does impact gloss more. Most of these materials show improvements in mar resistance. It's seen at low use levels and is only slightly improved at higher use levels. So if you want mar resistance, you don't need much stuff. Only FS1 reduces slip, and stain resistance was similar, but the more you use, the more property you got, the more performance. Quickly here, I didn't talk about the details of this, but these silicone materials are very good for graphite and waxy materials. The high CF2 materials are better for waxes, and higher molecular weight may make a difference. But importantly, the more you use, the better it gets. The last of these, I won't go through. I know you guys have a handout available to you. These are recommendations of these product lines depending on your specific system. So all of these results are rolled into these next three charts and really used as a guide, a usage guide. I didn't mention this, but the two polyether materials are commercially available. They're very good for everything except fingerprint resistance. The FA3 is a developmental product that we're commercializing. We've made samples now and have them available. And use levels up to 5% is recommended for that. And finally, thank you.